In this video, we will be reviewing Chapter 10, which is all about circles, in your geometry textbook. The very first part of this video, I want to discuss just a couple of definitions and parts and terms that we covered not only in Section 1, but we continuously used throughout the entire chapter. So just starting off with one, a tangent. So on your test, you're going to have to be able to identify some tangent lines. And here we only have one line, and that is going to be tangent AB. Alright, giving a proper symbol, it is a line, so we're going to include line. If you wanted to say that it was segment AB, that would also work. There is some flexibility there, or AB, a ray AB, or ray BA. Either one of those work for tangent. Alright, if I were to move on to secant, we need to remember that the difference between a tangent and a secant is that instead of passing through one time, it cuts through the circle twice. So one secant would be BC. Alright, and all you're going to have to do is list one. Alright, if I move on to a chord is contained within a secant. We have several options. So I've got AE. The endpoints are on the circle. BD is another chord, and BC is my last chord. We should be able to also identify a radius. Okay, looks like we have two, AF and EF. Right, a diameter. It's going to be AE. And last but certainly not least, we'll discuss the 2 points. So we've got a point of tangency, and the center. Alright, I've got 2 points of tangency. You could give me A or B, and I've got 2 centers, F or G. In this next example, we're going to be looking at finding measures of angles and arcs given central angles. Alright, so in this example, I'm only given 2 pieces of information here, and that is that the measure of angle AFB is equal to 80 degrees, and the measure of angle CFD equals 90 degrees. Alright, if I have a chord that passes through the center, that means that is a diameter. So it does chop the circle in half, which creates 2 semicircles that are worth 180 degrees. So that gives us some additional information here. So I want to start filling in what I know. I do know that these 2 angles right here are vertical angles. They're intersections by 2 straight lines, so this is also going to be 80 degrees. And since they're central angles, their corresponding arcs are also going to be 80 degrees. Right, so that's fairly simple to fill in. CD, arc CD is going to be 90 degrees as well. And then we need to find what arc BC is. Alright, and we do that by 180 degrees minus the sum of 80 plus 90 in order to find BC. So in symbols, for the record, in symbols, that is AD, or I guess we could say ABD, measure of arc ABD, minus the sum of the measure of arc AB plus the measure of arc CD, just so we know which arcs we're adding together and taking away. So that will give me the measure of arc BC, which is going to equal 10 degrees. Alright, so if this arc is 10 degrees, that means that angle is 10 degrees. And then last but certainly not least, it would be the same concept. We would take 80, this 80, away from a line in order to get angle EFA, and that would end up being 100 degrees, which makes this arc 100 degrees. Alright, so no matter what the questions asks, we should be able to figure out all of the parts first, which will help us answer the question. In the next example, we're going to be looking at a situation where I have two chords or secants that, two chords or secants that intersect in the middle or in the inside of a circle. So I'm going to put a dot there in the middle so that we know they don't intersect at the center. So we need to use a theorem where the product of two segments of a chord equal the product of the other segments of the other chord. So I'm going to have x times x plus 4 equals 2 times x minus 1. So we are going to have to distribute. X squared plus 4x equals 2x minus 2. Then we get x squared, subtracting 2x from both sides, plus 2x, and then we add 2, plus 2 equals 0. So if you can factor this nice and easily, I suggest that you do so and go ahead and solve for x. If you can't, which in this case we cannot, please use the quadratic formula. Alright, it will say to round to the nearest tenth or something like that. So x, all possible values of x equal the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So if we say, for example, our equation was actually different, if it was x squared plus x plus or minus 12 equals 0. That would factor easily into x plus 4 x minus 3. Therefore x would equal negative 4 or 3, and we'd have to verify that negative 4 wouldn't work because over here we can't have a negative value for a length. So that means x equals 3 is our winner. Now this example covered the inside intersection, versus our next example, which covers an outside intersection. Alright, so here if we're talking about the segments of secants, instead of just strictly multiplying the segments, we have to consider what pieces we're multiplying. So in this theorem, we used the exterior segment, so that would be x times the sum of the exterior segment with the interior segment. So the entire segment. Exterior times the whole. Okay, so we would have to distribute. We can combine our like terms and then distribute. In either case, we'll get 5x squared equals 5 times 20, or 100. And then we divide and we get x squared equals 20. X equals the square root of 20. And if you're remembering correctly, if I were to ask for an exact solution, that would be square root of 4, square root of 5, or 2 radical 5. However, it is likely on the test I'll just have you round instead. Now, instead of talking about the segments, we're going to go ahead and talk about the angles and the arcs instead. In this example, we want to solve for the variable x. So x is an angle. And we had written on the board just kind of a rough sketch. Typically, the angle is going to equal 1/2 of some sort of sum or difference dealing with arcs. So here we have our x, that's our angle, equals 1/2, and since this is an inside, we're going to be adding, inside intersection here, 184 plus 60, 1/2 of 244, therefore x equals 122 degrees. And if we were to logically look at the picture, that would make sense. It looks like it's over 90 degrees most of these pictures should be approximate and actually make sense with how they look. In this next example, our intersection is outside, which means we are going to be subtracting. So our angle equals 1/2, something dealing with the arcs. So our angle y equals 1/2 times, now since it's outside and we are subtracting, we are going to start with our larger arc minus our smaller arc equals 1/2 of 56, or 28 degrees. Y equals 28 degrees. In our next example, we are given an inscribed angle, and we want to find the measure of arc AB. So the difference between an inscribed angle and a central angle is that the vertex moves to the edge of the circle and away from the center. So we did have formulas. The angle equals 1/2 the arc. That was our general sketch here. Well, our angle here is 60 degrees equals 1/2 the arc we're looking for, our intercepted arc. So in order to find the arc, we go ahead and double each side. So the measure of arc AB is 120 degrees. And it would be the exact opposite if I were given the arc instead. So if I say that it's 84 degrees and I were looking for the angle, I would have the angle equals 1/2 times 84, or it'd be 42 degrees. Inverse relationships. And this brings us to the last angle theorem that I kind of want to talk about here. If we have a tangent, so let's say we have a tangent, we know that there are 360 total degrees in a circle, yet there are only 180 degrees in a line. So if a tangent and a secant meet, these two angles still have to be supplementary, but the two arcs here are going to add to 360. So that means the circle and the measure of their arcs are going to equal double the angles, or the angles are going to equal half of the arcs. So if this arc over here was 158 degrees, I should be able to figure out angle 1. Right here is angle 1. And then I should be able to also figure out angle 2 and the corresponding arc to angle 2. So mathematically, the angle equals 1/2 the arc, typically speaking. Alright, so the measure of angle 1 equals 1/2 times 158 degrees. Alright, and 158 degrees chopped in half is 79 degrees. Okay, so we now know the measure of angle 1 is 79 degrees, which means we can easily find angle 2 by taking it away from 180 degrees. Alright, and that will result in 101 degrees. And we can double that to find our second arc, or we can take, so we can do 101 times 2, or we can do 360 minus 158. There's a little bit of flexibility there. In either case, we would get 202 degrees. And in our final section of this chapter, we discuss the standard form graphing and the equation of a circle in standard form, which is x minus h squared plus y minus k squared equals r squared. So if I give you the center point and the radius, you should be able to give me the standard form, or if I give you the center in any point on a circle, you should be able to also graph and give me the equation. So let's just do the one with a little bit more work here. So let's say there is a point, and it is 4, 3, and the center is at 2, 3. Alright, if I'm filling in my parts, I do have an x and a y here. That is my point. And I do have my HK, that's my center. So I get 4 minus 2 squared plus 3 minus 3 squared equals r squared. Okay, this piece disappears because it's 0 squared, or 0. This becomes 2 squared equals r squared. Therefore, r has to equal 2. Alright, that is one part. So when I go to plug that into my standard form here, I need to use my center as well. X minus 2 squared plus y minus 3 squared equals 2 squared. I am, however, going to write it as 4 also. If it was in standard form, I want you to go ahead and square it if that's your final answer. So x minus 2 squared plus y minus 3 squared equals 4. That would be your final answer for standard form. Alright, now for graphing purposes, it is nice to have that 2 there, so you can just go ahead and use that as your radius. Alright, so if the center is at 2, 3, here's the center at 2, 3, and if the radius is 2, I go up 2, down 2, right 2, left 2, and I try to connect them in the best possible way that I can. Alright, if you guys have any questions about any of the sections or formulas, please feel free to send me an email or see me before or after school. Good luck studying.